All right, it's time to learn about the average value of a function. And I always like to start off by saying that the average value of a function is really the average y value of a function, or the average height or distance from the x-axis of a function. And we're giving you here the equation that you'll see a lot and you'll memorize. The equation to find average value is 1 divided by b minus a of the definite integral of some function f of x from a to b. And I just want to show you before we go into it how we derive this. I want to show you that this is effectively another statement of the FTC part 1, which we know to be big F of b minus big F of a is equal to the integral from a to b of little f of x dx. Now, if I were to divide both sides of the equation here by b minus a, do you see how on the right side I have gotten the average value of a function? So the average value, or the average y value of our little f function, where little f is the rate of change function of big F. So the average y value of the rate of change function will be the average rate of change of the big F function. Let me see if I can explain this. The average value of little f, where little f is the rate function, it's the average y value of the rate function, is the same over here as the average rate of change of the position function. And you know this difference quotient from Algebra 1. So the average height of your rate of change function is the average rate of change of the position function. That's a lot to get your head around, and we're going to come back to it again and again, but I'm going to show you an example here. So we are assuming that C represents the cost of heating your house measured in dollars per day, where time is in days here, and the very first day here is January 1 of 2007. So that means that 31 days along is going to be January 31st, and let's see, 28 days later is going to be February 28th. And then 31 days later is going to be March 31st. Now, 31 days plus 28 days plus 31 days is a total of 90 days. So that's why we put 90 in this problem that we're going to have. So living in Northern Virginia, we might have the coldest time of the year sort of in the February time range. So the average cost to heat our home is probably increasing from January into February and then decreases into March. So let's just make up a curve here. The average cost of heating our home might start here, might go up into February, and then it might start to come down again, so that by the end of March, we're certainly paying less than we paid on January 1. Obviously, this graph could look different depending on where you lived in the world. Okay, so that is the possible graph of the cost of heating my home. So what do the following represent? Well, if I were to integrate this curve, and this is the C of T curve, okay, that's the dollars per day of heating my home. If I were to integrate it from 0 to 90 days, so find this entire area under the curve, I am effectively multiplying dollars per day times the number of days. So that is going to give me the dollars. And what does this represent then? This is going to be the total cost in dollars of heating my home on basically January 1 to March 31 of this given year. Okay, so if I integrate the rate that it costs me to heat my home per day, I'm going to get the total dollar cost of heating my home. Well, now let's take a look at this average value. So I've taken the total cost here from 0 to 90, the integral of big C is the total cost in dollars, but then I'm dividing it by those 90 days again. So the units once again become dollars per day because I'm taking the total dollar cost and I'm dividing it by the number of days. This is going to be the average cost per day of heating my home. So in dollars per day, average cost per day in dollars per day of heating my home on, of course, the same time period, January 1 to March 31. Okay, so let's talk about how we got the average from a graphical standpoint. I'm going to come up with another color here so I can make it really clear. Let's pull the purple. If I were to integrate this whole region, find this area, and then divide it by the number of days, I'm going to get the average y value of this C of t curve. And so if I were to try to sketch in the average y value across the 31 days, I might get something that looks like this. This would be the average height of the function, or the average y value. And you will know that you have it right if these regions, the ones that are below the average height but bounded by the curve, and those that are above the average height that are bounded by the curve, if these all net out to 0, then I have found the average value. So think about this. Think about, you've got a box of sand, and you take the box of sand, and the sand is all lumpy. It's different heights. You know, you just kind of threw the sand in there. You didn't pay attention. And then you take the box of sand and you shake it, and so that you even out all of the sand. And so now all of the sand is level. That is what you're doing when you're finding the average value. You're taking something with a variety of different heights and you're leveling it out to find the average height. So that's what we've done in this example. Okay, next example. This one is a calculator example. They're saying that the population of Mexico is modeled by this given exponential function where p is in millions and t is in years since 1980. And they want you to predict the average population of Mexico between the year 2000 and the year 2020. What are the units? Well, first of all, since 1980, 2000 is 20 years, so that's our lower limit of integration, and 2020 is 40 years. So what we're going to do is we're going to integrate this population function on the interval from 20 to 40, and then to find the average population, we are going to divide by 1 over 40 minus 20. And then you could just put this in your calculator. You integrate from 20 to 40, and then you're going to divide by 40 minus 20, which was just 20. And when I put that in my calculator, I get 147.133, and that is going to be in millions of people. And that would be the average predicted population of Mexico on the interval from the year 2000 to the year 2020. That should say the word of right there. Okay, and then the last, this one is not set in any real world scenario. We're just finding the average value of a function on an interval. So we're going to integrate the function 3x squared dx on the interval from 0 to 4. And then we are going to multiply by 1 over 4 minus 0. So we can go ahead and do this one by hand. We can integrate 3x squared. We'll integrate to x cubed. And we evaluate it from 0 to 4. And then we are going to divide by 4. So 4 cubed is 64, minus 0 cubed, which is 0, all over 4. And my answer here will be 16. And that basically says that the height, the average height of the function 3x squared on the interval from 0 to 4 is 16.